Just a moment. I need to switch on one more time. Demonstration. Okay, so what was the second problem? So in this case here, we have this e to power of this function. We need to consider again limits, as Kamala said. So limits as x tends to plus infinity and x tends to minus infinity. So, and then we can conclude about the function. So this function will be bounded above, and asymptotes. What is horizontal asymptotes? Here you can see in 3 versions here we have answer horizontal asymptote. So what is horizontal asymptote? When it has horizontal asymptote? Yes, here only plus infinity. Sorry, I cannot see this one. X tends to plus infinity. We need to check asymptotes. In previous one, in B1, x tends to minus infinity. But to consider each cases, we don't know here, for example, the solution, yes? To consider each cases, you need to consider here all this x plus infinity and x minus infinity. But when you do it, so when you check, yes, correct. E to the power of x is increasing function, yes, but e to the power of minus x, decreasing function, yes, which is greater than 0, correct? Bounded by a x-axis, yes, o x-axis, yes. So here, as x tends to plus infinity, what will be the limit? In this case, what will be the limit? Infinity. I'm going to set plus infinity. Do you agree with the solution? So I ask it, do you agree or not with plus infinity? I'm not saying it's correct or not. So yeah, horizontal asymptotes here, when x tends to plus infinity, here you can see infinity minus infinity, which is not gives us the correct result. So you need to solve it by, so sorry, is there more comments? Let me read these comments, just a second. So it has an asymptote at plus infinity because tends to 0 at plus infinity. Then horizontal asymptote 0. Next answer here is I think limit of this function is 0. Okay, so the limit here, it tends to 0 or plus infinity? Tends to 0, yeah. So when it tends to plus infinity, that's why it will be a horizontal asymptote. So at the plus infinity, we have horizontal asymptote. Yes, and now this will be correct. So the correct answer here, that's why Z1. So we need to check. Is it maximum or minimum? We have the point. There was natural logarithm 2 over 3, yes, or 2 over 3, yes, with minus, yeah. We need to check, is it maximum or minimum, of course. And then, and then we can say the correct answer here. Because you can see here, we have two almost same answers, D and E. So here, maximum, here, minimum. You need to check, is it maximum or minimum? Okay. How to check? You know, if it moves from plus to minus, what it will be? From minus to plus. So that's why you need to, I will say one more time, you need to check maximum and minimum in this case, okay? Next, number 3, I think it's clear now. Number 3, consider the function f of x. The derivative, this function is, find the derivative here. Find the derivative. Can we skip it? Not, you don't have problem, I think here. The correct answer will be E1. Here we can see the composite functions. E to the power of x multiplied by arcsine. What will be the derivative of arcsine? 1 over square root of 1 minus x squared, yes? So, and we will use here this formula for arctangent. You know, what is arctangent formula? 1 over 1 plus x squared. So, and I think we can skip. Square root also, square root in arcsine. Okay, now find principal part. We have find principal part. We have question number 5, x0 minus 0, x0 plus 0. Find one-sided limits here. It's given function, x0 is 1 here. Find one-sided limits. How to find here one-sided limits? X0 minus 0 and x0 plus 0. So 1 minus 0, 1 plus 0. Find the limit. Limit as x tends to, just a second, as x tends to, first of all, of course, you need to consider here the limit. In this case, tends to, I mean, here 1 minus 0 and 1 plus 0, we need to consider. So first of all, limit n tends to, look, limit n tends to infinity, and x tends to, so 1 minus 0 and 1 plus 0. So here xn, 1 plus xn. So if it is smaller value than 1, 1 minus 0, left side of the 1. So where it tends now? Sn tends to infinity, of course.
Tends to 0 because numerator
0 because, yes,
0.
base will be smaller than 1, yes? And the power of infinity, which gives us it tends to 0. This tends to also 0. So it tends to 0 over 1. It will be just 0. When limit as x tends to 1 plus limit n tends to infinity, here n we have. So xn divided by 1 plus xn. So where it tends now?
It tends to 1 because x in power n now tends to infinity. So it will be just 1 over x over n, xn or xn.
And also here we have the same powers, yes? Same powers in numerator and in denominator. That's why here we can use just since they have same powers, so we can say it tends to 1 in this case. So could x1 minus 0 be interpreted as x tends to 1? So x1 minus 0, it is left side of the 1. So since we have two sides of the, is it visible? Sorry. So it is 1 minus epsilon and 1 plus epsilon. Neighborhood of the 1.
Yes. Recording stopped.
Just a moment. Now I think it's okay.